Dave Staublin here, and I have a question for you. What happens when we need to add lots of terms in a series? For example, we have a problem here that says we want to sum from n equals 1 through 75. That means 75 terms that we need to add up of this sequence. Now, one of the questions you might run into is, can you tell what kind of sequence this is by looking at the equation? Well, this is an arithmetic series because we have a starting value, a common difference, and the n minus 1. So one of the things that we could do is that we could rewrite this equation 75 times, and we could plug in 1, then 2, then 3, then 4, and so on and so forth, all the way up to 75. Plug all those numbers in for n, and then add them all up. And that would take a long time. Well, it turns out that there is a shortcut. And here's how it works. It's very specific. It applies for a finite arithmetic series. Okay, so for one of these only. If this is what we have, then the sum, now this is a regular s, the sum of n terms is n divided by 2 times a sub 1 plus a sub n. Now, this notation is very confusing because these n's in this equation work differently than all the other n's that we've been using in our equations. Because what this is going to do is this is going to give us a shortcut for this summation. And so this n is the total number of terms in our series. Okay, and that's that term and it's that term. And then here's where it gets doubly confusing. And this n represents the nth term in the series. So that's the last term. And this one represents the first term in the series. Wherever we start, this is the first term, and wherever we end, that's the last term. Okay? So let me show you how that works. Okay, I'm going to rewrite this. We would say that the sum of n equals 1 to 75 of this equation, 6 plus 3 to the n minus 1, is going to be equal to n over 2, where n is the total number of terms in our series. Well, how many do we have? We have 75 terms. And then a1 is going to be the value of the first term. Well, how in the world do we get that? Well, the way we get that, the first term in the series is going to be 6 plus 3, and then the n value goes in, 1 minus 1, and so 0 times 3 is 0 plus 6 equals 6. That's the first term. Now what we have to do is we have to put in the last term. And so how do we get the last term? Well, we do this equation, 6 plus 3 to the n minus 1. And what is the n value of the last term? 75. And so I'm going to break out the calculator for that one. And 75 minus 1 is 74 times 3 equals plus 6 equals 228. 228. So now we can plug that in And if we evaluate this, we'll know what the sum of this series is. So my calculator's off the side of your screen, but 6 plus 228 equals times this fraction 75 divided by 2. And we get 8,775. So that is the sum of all 75 of these terms added together. Now, you're going to have to trust me that this is right, unless we do a little test with a shorter sequence, or a shorter series. And I think we can do that. Let's go back to this problem. Now I'm going to raise this up a little bit so we can keep track of our formula. When we did this before, we did this all out the long way. But now that we know the shortcut way, let's do it. Oh, and again, remember, this only applies to an arithmetic series, and I think this is arithmetic because it looks like we're adding 5 every time. Okay, so for arithmetic series only, this one applies. So the sum of n equals 1 to 3 of 5n plus 1 is going to be equal to, oops, you can't see that. Our shortcut formula is n over 2, where n is the total number in a sequence, or in a series. So 1, 2, 3, there's going to be 3 terms. And then this first number is the value of the first term. So you would take 1 and plug it in. 5 times 1 is 5, plus 1 is 6. And then we want to add the value of the last term. And the last term you get by taking this number and plugging it in. So 5 times 3 is 15, plus 1 is 16. Okay, so now we just add those up. And let's see. 6 plus 16 is 22, times the fraction 3 divided by 2. And we get 33. And so you can see that our shortcut formula worked just the same as doing all the work out the long way. So this is a real time saver when you have to add a lot of terms together.